So a function is a process for turning one number into another number. So I like to imagine it in my head like something like this. That x becoming y, for example. Um, so, for example, if I have a function of y equals 2 times x, I could plug in a 3 for an x, and so y would be 2 times 3, so y would be 6. So in this case, this input, or what we start with, is called the independent variable. The output is called the dependent variable because it depends on what the input is. So here's a normal way to write a function in terms of two variables. We got y, the output depends on x, the input. So this is um, y as a function of x, meaning we plug stuff in for x, we do this process to it, we square it, multiply by 3, add 1, and then we get the output, which is y. So you can write functions like this, these relationships between two numbers, in function notation. And here's the same exact function, but written in function notation. So instead of this output variable, calling it a different variable, like y, we actually have the name of a function. So we could call this function f. And in function notation, we would say f of x. That's what the parentheses mean. Of f of x. And then we just specify when you put x into this function, what does this function do to x? Well, we square x, then we multiply 3, and then we add 1 to it. So here's where you put the input variable, or the independent variable. And then the output variable, or the dependent variable, is just f of x. It's the function itself. F of x would be the same thing, or equivalent to y. Okay, so it's really we're really talking about the same thing here. In one case, we're defining a variable in terms of another variable. In this case, we're talking about a function defined in terms of a variable. So you can actually rewrite every equation with two variables as a function. So in this function here, y is defined as a function of x because if I plug stuff in for x, I get the value of y. So let's say pretend I plug in 4 for x here. 2 times 4 is 8 minus 7. 8 minus 7 is 1. So if x is 4, then y is 1. So I'm defining y in terms of x, or the value of y depends on x. So if I wanted to write that in function notation, I could just get rid of this dependent variable, the output, and replace that with the function notation. So first step would be just to call your function something. It can be any letter. People usually do F. Let's just for fun, let's do G. And then here's the function notation, G with the parentheses. And inside of that, you say what the input variable is. So in this case, it's x, because x is I'm plugging in values for x and doing stuff to it. So I'm multiplying by 2 and subtracting 7. So this I would call g of x, and then I would just describe what you do with x once you put it into the function. So it's same thing here, 2x minus 7. Alright, so here's an equation where p is defined in terms of m. So my input is going to be m, and my output is going to be the function, whatever I want to call it. So let's be boring. Let's just call it f, and we've named our function. Okay, and in function notation, make these parentheses, and I like to look at it as like a big mouth. Here, you put the food into the function, and then you describe how to chew it up. I don't know if that works for you. So in here we put the independent variable, or the input variable. So in this case, it's m, so f of m, is equal to, and then we describe what we have to do to m to turn it into f of m, so 2m minus 7. All right, well let's take a word example here. There are 3 times as many bears as cows on my couch. So I could write a function that says how many bears I have as a function of how many cows. So however many cows there are, you multiply by 3 to get bears. So let's name the function, and in this case, let's just call it b, so that we I don't like that one, b, so that we know we're talking about bears. We're defining bears in terms of the other variable. Okay, so b. What is our input variable? It's going to be cows. Let's just call that c. And then how do we turn cows into bears? Well, there are 3 times as many bears as cows. So however many cows we have, we've got 3 times as many bears. So we'd have c for cows, and you just multiply it by 3. So here's a function of bears in terms of cows. Okay, what if you had a situation like this, where you've got 2 variables, and they're defined in terms of each other, but there isn't kind of an obvious output variable. We don't have a variable by itself on one side of the equation with the rest of the stuff in the other side of the equation. Well, in this case, you just decide what variable you're going to define in terms of the other. So let's rewrite this as x as a function of y, and that's just to mix things up. Usually it's the other way around, so I'm feeling a little bit rebellious today. So let's define this as x in terms of y. So we need x by itself. So x is being multiplied by 4. So all we need to do is divide both sides of the equation by 4 to get x by itself. So we get x is equal to this is a 4. So 2 divided by 4, 2y divided by 4 is 2/4 y, or if we would simplify that to 1/2. 1/2. Oh, no wonder I can't see it. Let's see here. There we go. 1/2 y, and then minus the 8 divided by 4 is 2. So now we've clarified this situation. Now we've got x is a function of y. Alright, so meaning if I plug in a y, then I do all this stuff to it, and I get the x. So our dependent variable is going to go away. We're just going to name the function instead. So let's just call it g again. Kind of lacking in imagination in this moment. G. What's our input variable? What do we plug in to get the result? Well, in this case, it's y. So g of y. And then we describe how do we turn a y into a g. It's 1/2 y minus 2. Pretend like that's a 2.